Welcome back to Low-Level Programming Crashcasts. I'm Sheila, and as always, I'm joined by the amazing Victor. Before we dive in, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more learners like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're wrapping up our chapter on Introduction to Assembly Language with a comprehensive summary. Are you ready to tie everything together?
Absolutely, Victor. But before we start, I have a quiz question for our listeners. Here it is. What's the key difference between assembly language and machine code? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of what we've been discussing in this chapter. I'm curious to see how many of our listeners can get this right. It's not as straightforward as it might seem at first glance.
You're right, Victor. It's a bit tricky. Now, let's start our summary by recapping what assembly language actually is. Can you give us a quick refresher?
Certainly, assembly language is a low-level programming language that's specific to a particular computer architecture. It's a step above machine code in terms of human readability, using mnemonic codes to represent machine instructions. Think of it as a bridge between the ones and zeros of machine code and the more abstract high-level languages like C or Python.
That's a great explanation, Victor. I like to think of assembly language as the blueprints for a building. It's not the actual bricks and mortar, that would be machine code, but it's a detailed plan that's much easier for humans to understand and work with. Is that a fair analogy?
That's an excellent analogy, Sheila. Just like blueprints guide the construction of a building, assembly language guides the execution of a program. Now, let's move on to the relationship between assembly and machine code. What's your understanding of this, Sheila?
Well, from what we've learned, assembly language is a human-readable representation of machine code. Each assembly instruction typically corresponds to a single machine code instruction. However, assembly uses mnemonics and symbols instead of binary or hexadecimal codes. Is that correct, Victor?
Spot on, Sheila. And this brings us to an important point about the role of assemblers. Can you explain what an assembler does?
Sure. An assembler is a program that translates assembly language into machine code. It's like a translator that takes our human-readable assembly code and turns it into something the computer can directly execute. But Victor, I'm a bit confused about the difference between assemblers, linkers, and loaders. Can you clarify that for our listeners?
Absolutely, Sheila. This is where things get a bit more complex, but it's crucial for understanding how assembly programs become executable. Assemblers, as you correctly said, translate assembly to machine code, but they produce object files, not executable files. Linkers come into play when you have multiple object files or when you're using libraries. They combine these files, resolving references between them to create a single executable file. Loaders, on the other hand, are part of the operating system. When you run a program, the loader takes the executable file, loads it into memory, and prepares it for execution.
Wow, that's quite a process. You know, it reminds me of how a book is made. The assembler is like the writer who creates the manuscript. The linker is like the editor who puts all the chapters together and makes sure everything connects properly. And the loader is like the person who puts the book on the shelf, ready for someone to read it. Does that make sense?
That's a fantastic analogy, Sheila. It really helps visualize the process. Now let's talk about something practical. Remember when we wrote our first assembly program in this chapter?
Oh yes, that was exciting and a bit intimidating at first. It really drove home how different assembly is from high-level languages. Can you remind our listeners of some key points about writing assembly programs?
Certainly. When writing assembly, you're working directly with the processor's instruction set. This means you have to manage things like register allocation and memory management yourself. It's very low level, giving you precise control over the hardware, but it also means you have to do a lot of work that higher-level languages would handle for you. One interesting anecdote is that in the early days of computing, all programs were written in assembly or even directly in machine code. Imagine debugging a program where a single misplaced instruction could cause everything to go haywire.
That sounds incredibly challenging. It really makes me appreciate how far we've come. Speaking of challenges, what are some common pitfalls or misunderstandings that beginners often encounter with assembly language?
Great question, Sheila. One common misunderstanding is thinking that assembly is always faster than high-level languages. While assembly can be extremely efficient when done right, modern compilers for high-level languages are very sophisticated and can often generate equally efficient or even better code. Another pitfall is underestimating the importance of commenting assembly code. Because it's so low-level, it can be hard to understand what a piece of assembly code does without good comments.
Those are great points, Victor. It seems like assembly is a powerful tool, but it needs to be used judiciously. Now, as we wrap up, can you give our listeners some key takeaways from this chapter?
Absolutely. Here are the main points to remember. 1. Assembly language is a low-level programming language that's architecture-specific. Point 2. It's a human-readable representation of machine code, using mnemonics instead of binary. Point 3. Assemblers translate assembly to machine code, linkers combine object files, and loaders prepare programs for execution. 4. Writing assembly gives you precise control, but requires managing many low-level details. 5. While powerful, assembly isn't always the best choice. Modern high-level languages can be just as efficient in many cases.
Excellent summary, Victor. And now it's time to reveal the answer to our quiz question. The key difference between assembly language and machine code is that assembly language uses human-readable mnemonics and symbols, while machine code is pure binary or hexadecimal that's directly executable by the computer. Assembly needs to be translated by an assembler before it can be executed.
Great explanation, Sheila. I hope our listeners found this summary helpful. As we close out this chapter on assembly language, remember that understanding these low-level concepts can make you a better programmer, even if you primarily work with high-level languages.
Absolutely, Victor. And to our wonderful listeners, thank you for joining us on this journey through assembly language. If you enjoyed this episode, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep creating this content. Don't forget to subscribe and rate our podcast. Until next time, keep coding and stay curious.